Picture a driver on a crowded motorway, fighting the onset of severe fatigue. As the car moves at high speed, the physical demand for rest becomes impossible to ignore. The brain is biologically wired to prioritize survival above all else, yet in this moment, it triggers a state of unconsciousness that almost guarantees a crash. This happens because sleep functions as an involuntary biological override. It is a mandatory requirement that the brain will execute regardless of the external danger. The override is triggered when our neural networks reach physical capacity from a constant stream of sensory stimuli. The brain runs out of space. If the driver rests for 10 minutes, the cortex processes this backlog, clearing space to take in new information. Sleep is an intense, active physiological process dedicated to managing this sensory overload. It is so vital to our internal maintenance that the brain will risk death to ensure the work gets done. Healthy sleep follows a rigid biological algorithm, organized into cyclical phases that last roughly 100 minutes each. Every cycle builds toward a final stage defined by rapid eye movement, or REM. While the body remains perfectly still, the cortex enters a state of vigorous activity. Electrical frequencies in the brain during REM often match or exceed the levels we see when someone is fully conscious. During this window of hyperactivity, the brain is sorting and filing the day's sensory data. We experience this intense processing and information management as dreams. Dreaming isn't a random byproduct. It is the observable result of the cortex working overtime to handle the day's information. We can see the stakes of this process in people with fatal familial insomnia. It's a rare genetic disorder where individuals lose the physical ability to fall asleep. Without the ability to process sensory data and rest, the body's functions lose coordination. The result is a slow, certain failure of all internal systems. Even in healthy people, chronic sleep deprivation causes a measurable decline. It is linked directly to an increased incidence of malignant tumors, heart disease, and impaired cognitive function. We cannot simply choose when this repair happens. Humans are diurnal larks. Our brains require the specific environment of nighttime darkness to trigger the repair cycle. When our environment goes dark, the brain begins secreting melatonin into the bloodstream. This hormone serves a protective role. It travels to our cell nuclei to shield the DNA during the high-intensity repair work that occurs while we sleep. Sleep is about more than just feeling rested. Without the nighttime secretion of melatonin, the brain loses its primary tool for protecting the body at a cellular level. Our biological requirements are fixed, yet modern life often forces us to work against them. Sleeping during the day after a night shift provides what researchers call jump sleep. While it might reduce the feeling of tiredness, day sleep lacks the nutritional value of night sleep because the brain cannot trigger the same restorative processes in the light. Physical conditions can also break the cycle. In sleep apnea, the airways narrow and block the flow of oxygen. The brain detects the drop in oxygen and forces a micro-awakening to restart breathing. This interrupts the vital data processing cycle. To fix this, a CPAP machine delivers pressurized air to keep those airways open and the sleep cycle intact. These mechanical and environmental disruptions prevent the brain from reaching the deep, restorative phases it needs to maintain the body. Today, the most common disruption to our sleep algorithm is the blue light emitted by our screens. Blue light consists of short, high-energy wavelengths. Because of this energy level, these waves can penetrate the eyelids even when our eyes are closed. When this light reaches the deep brain, it is interpreted as daylight. The brain responds by immediately halting the secretion of melatonin. This cutoff is dangerous. Melatonin allows the brain to monitor vital processes throughout the body. When production stops prematurely, the brain's ability to oversee internal maintenance is reduced, meaning critical tasks like the elimination of newly formed cancer cells can be missed. Sleep is a rigid, non-negotiable algorithm. To protect our health, we have to defend our environment from light and distraction, giving the brain the darkness it needs to clear the backlog.